Thanks for joining me again, guys, to another one of my mathematics tutorials. In this session, we will be looking at indices. Indices is the plural of the word index. Now, what is an index number? So, an index number looks like this. This is said to be a number written in index form. Now, you are going to see one number appear larger than the other number in font. When I say in font, we know that 5 is numerically larger than 2. However, the 2 is written bigger than our 5. Now, we refer to this number that is written bigger as the base. And this small number at the top right hand side is called index. There's another word for it. Sometimes it's referred to as power. And it's also known as exponent. So that little number there has three names: index, power, or exponent. Now, what this number means, this index number, it means that this 2, which is your base, is multiplied by itself 5 times. So that index there tells us how many times our base is multiplied by itself. Now let us look at another example. Let's say we have the number 3 to the power of 7. What this means is that we multiply 3 by itself 7 times. So that's 3, 4, 5, 6, 7. So it's 3 multiplied by itself 7 times, and this is not equal to 7 multiplied by 3. So do not confuse your expansion of an index number with this part here. Remember, 3 by 3 is 9, and 9 by 3 is 27. 27 by 3, you work that out, and you just continue to multiply by 3. Unlike here, you have 7 multiplied by 3 to give 21. So do not confuse the two here. Now, there are some exceptions to this rule, and we are going to look at them now. Okay, so I'm going to write our rules here. We have rule number 1. Our first rule is that any base that is raised to the power 0 is going to give us 1. So let me write, for example, 5 raised to the power 0 is going to give me 1. 8 raised to the power 0, 1. 100 raised to the power 0 is going to give me 1. So any number that is raised to the power 0 gives 1. And I'm going to write that in a general form. So I'm going to use x as my base. And I am going to say x raised to the power 0 gives 1. And that is our first rule. X representing any number that you put there. Whatever number you put x as, x is your base, and you raise that to the power of 0, you are going to get 1. Now, there's actually an exception to that rule number 1, and it's 0 raised to the power 0 is not 1. It's actually undefined. So the only exception to that rule is 0, because 0 raised to the power 0 is not 1. It's undefined. So let's move on to our rule number 2. Our rule number 2 states that any number that is raised to the power 1 is itself. So for example, 5 raised to the power 1 is going to give us back 5. 10 raised to the power 1 is going to give us 10. 1000 raised to the power 1 is going to give us back 1000. 81 to the power 1 is going to give us back 81. So we are going to write rule number 2 in a general form. We're going to use back x to represent our base. So x, which represents any number, raised to the power 1 is going to give us back x. Okay, so our rule number 3 is going to be where we have a negative number for our power. So for example, let's say 12 is raised to a power of negative 2. Now what this is simply 1 over 12 to the power 2. Now what we can think of it as, this negative sign is simply using a numerator of 1. So we just put 1 as our numerator and we use 12 to the power 2 as our denominator. So let's look at another question. Let's say we have 20 raised to the power negative 4. This is simply 1 over 20 to the power 4. Let's say we have 92 raised to the power negative 8. This is simply 1 over 92 raised to the power 8. So let's write rule number 3 in a general form. Let's use x again, x being our base, and we are raising this to the power negative a, where a represents any number, right? And it's a negative power we are dealing with, so we have negative a. This is going to be 1 over x to the power a. And I just explained that rule with these 3 questions here. So x to the power negative a gives us 1 over x to the power a. Let's look at rule number 4. Rule number 4. Let's say now we have 2 index numbers being multiplied by each other. So let's say we have 3 to the power 2, and I'm going to multiply that by 3 to the power 4. Now let's see if we can analyze this. 3 to the power 2 is simply 3 multiplied by 3. And this now is being multiplied by 3 to the power 4. And I know 3 to the power 4 is 3 by itself 4 times. Now if I look at this entire thing here, I'm going to see that 3 is actually being multiplied 6 times. So we can write this as 3 to the power 6. Now when we examine our 2 indices, we are going to see that what we did in order to arrive at our answer where the power is 6, we simply added our 2 indices. So 4 plus 2 is 6. So let's have a look at another one. Let's say we have 2 raised to the power 5 multiplied by 2 raised to the power 4. This is actually 2 by itself 5 times multiplied by 2 by itself 4 times. How many times in total did I multiply 2? I'm going to notice I multiplied 2 by itself 9 times. So what we did is we simply added 5 and 4 and we got 9. So to write this rule in a general form, I can say x representing a base, and I raise that to the power a. If I multiply that by x, now notice we had the same bases. I had 2 here and I also had 2 here, and that is how we could have written back our same base here. So we need to have the same base in order for this rule to apply. So we are writing x to the power a multiplied by x to the power b to give us x to the power a plus b, because that is what we have to do. We have to add our powers to arrive at our answer. So x to the power a multiplied by x to the power b gives x to the power a plus b. Now, what if we had 2 raised to a power of 3 and we are multiplying that by, let's say, 5 to the power 2? This rule will not apply. Rule number 4 will not apply simply because we have different bases. So this rule will not apply. We will have to work this out separately. Let's look at another rule. Rule number 5. Now, what if we had 10 to the power 5 divided by 10 to the power 3? Now, we know 10 to the power 5 is actually 10 by 10 by 10 by 10, right? 5 times. And we are dividing this by 10 to the power 3. So it's 10 by itself 3 times. Now, what will happen is that we can cancel that 10 there, we can cancel that 10 there, and we can cancel another 10 there, leaving us with 10 by itself 2 times. So I can write this as 10 to the power 2. So what happened to these powers here? How did I arrive at 2? Notice 5 take away 3 gives us 2. So what we did, we took it away. So let's see now if this is going to apply in another question like it. So let's say we have 8 to the power 9 divided by 8 to the power 2. So we know 8 to the power 9 is 8 multiplied by itself 9 times. And we are dividing this by 8 to the power 2, so it's 8 by itself 2 times, and we can cancel this with this and this with this, leaving 8 multiplied by itself once, twice, 3 times, 4, 5, 6, 7 times. So our answer here is going to be 8 to the power 7. And notice how we arrived at 7. It was 9 take away 2 to give 7. So yes, that rule works for that, and we are going to write that now in general form. If we had x to the power a and we are dividing it by x to the power b, it's going to be x to the power a take away b. So when we are dividing indices with the same base, and notice we have the same base, what we must do is subtract our powers. So that's rule number 5. Let's look at rule number 6. Okay, so let's write rule number 6 here. Now let's consider something like this. 2 raised to the power 4, and that now is raised to another power of 3. Now what this is telling us is that we need to multiply 2 to the power 4 by itself 3 times. So what this is 2 to the power 4 by 2 to the power 4 by 2 to the power 4. Because it is being raised to the power 3. So it is telling us that we need to multiply what is in that bracket there by itself 3 times. And that is how we arrive at 2 to the power 4 3 times. Now, what is 2 to the power 4? It's 2 by itself 4 times. So this is actually this part here. And now we have to multiply that by 2 to the power 4. And then multiply that again by 2 to the power 4. So we have this 3 times, and in total, if we look, how many times are we actually multiplying 2 by itself? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we are actually multiplying 2 by itself 12 times. So let's analyze these powers. I had 4 and 3 and I ended up with 12. So what it seems to appear as is if I had multiplied 4 by 3 to get 12. Let's look at another question. So let's say I have 4 to the power 5 and I want to raise that to the power 2. So what this simply means is I am going to take what is in this bracket here and multiply it by itself 2 times. So I'm going to get 4 to the power 5 by 4 to the power 5. So this is going to give us 4 by itself 5 times. And here, same thing, 4 by itself 5 times. And these two are being multiplied. So how many times in total am I multiplying 4? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 4 to the power 10. So let's examine these. I have 5 and 2 and I got 10. So yes, we did multiply 5 by 2. So let's write our general rule for rule number 6. If I have x being any number for our base, and it is raised to a power a, and that now is raised to another power, let's say b, what we must do is we put back our base and we simply multiply our powers. So we get x to the power a multiplied by b. So that's our rule number 6. Now on to rule number 7. Now this rule is simply one that you may not be able to analyze and that you may just have to learn off. Is one that looks like this. Let's say you have 3 to the power 2/3. So we are seeing that our index here is a fraction. Now when this happens, we simply find our root of our base. So we put our base in that root, and this denominator here is going to tell us what type of root we need to find. So I'm seeing 3 as my denominator, so I know I have to find the cube root of 3. And this 2 here is going to tell us that we need to find the square, or we need to say 3 to the power 2 and then find the cube root of that. So let's take another example. Let's say we have 4 to the power 8 over 11. This simply means I say 4 and I look at my denominator. I find the 11th root of 4 raised to the power 8. Let's have a look at one more. Let's say I have 10 to the power 3/4. So my denominator is going to tell me what type of root I need to find. So this is going to be the 4th root of 10 raised to the power 3. So in general, this is going to look like x to the power a over b. Remember, our power here is a fraction, and this is going to be b root of x to the power a. So this is our general rule there. And for our rules before, we actually were able to analyze them and see how we came about with the rules, but this one is a little technical. So you may just have to learn off this one, right? Where your power is a fraction. So that's it there. That's your rules of indices. Thank you very much for watching.
Don't forget to like, share and subscribe for more of my videos.